Assalamualaikum and a very good morning. My name is Ahmad Haris Ilham bin Ahmad Tarmizi. My metric number is B13231029. Today, my group and I will present about risk assessment and risk management proposal for heavy vehicles on Malaysian roads. So this is my group members. So the table of contents that we got in our presentation is introduction, objectives, hazard identification, risk assessment, risk control measure, risk management framework, and the last one, conclusion. So firstly, I will explain about introduction of our presentation. As we know, heavy vehicles are essential for Malaysians' transportation and logistic industry. They transport passengers, goods, and raw material across the country. Accidents involving heavy vehicles often result in severe injuries, fatalities, and property damage. And lastly, effective risk management is needed to improve safety and reliability.
I'm Chikahin, and right now I will start for my part. So let's look at the core objective of our proposal. Our primary goal is to establish a comprehensive framework that addresses heavy vehicle safety from all angles. First, we aim to identify the key hazards associated with heavy vehicle operation on our roads. Once identified, we will assess the likelihood and severity of these risks to understand their potential impact. Beyond the vehicle themselves, we are also evaluating the external factors that affect road safety, such as environmental and human elements. Ultimately, this allows us to propose suitable, actionable risk control measures. By achieving this objective, our end goal is to significantly improve the overall reliability and safety performance of heavy vehicles operation in Malaysia. Next, which is hazard identification, where we look at the major risks and their immediate consequences on the roads. We have categorized 5 critical hazards. So, first one, driver fatigue. This leads to the dangerous loss of concentration and speeding, which exponentially increase accident severity during a crash. And brake failure, a mechanical hazard that results in catastrophic loss of vehicle control. And overloading, this alters the vehicle center of gravity, causing severe vehicle instability. And last, poor weather, an environmental factor that leads to drastically reduced visibility. Recognizing this specific hazard allows us to move from pointing out the problem to calculating the actual risk that is posed. Next is risk assessment. So to prioritize our effort, we conduct a formal risk assessment to calculate a risk score and determine the risk level for each hazard. As you can see from the result, driver fatigue topped our risk with a score of 25, placing it squarely in the extreme risk category. This demands immediate and aggressive intervention. Following closely behind are speeding and brake failure, both scored 20 alongside overloading at a score at 16. All these 3 falls in the high risk category, meaning they pose a constant severe threat to public safety. Finally, poor weather. What scored a 12, which classifies it at a medium risk, still highly significant, but more manageable through adaptive driving. Next, which is risk control measure. So to tackle this extreme and high risk, we propose a 3-tier approach to risk control measure. We break this down into engineering, administrative, and maintenance control. First, under engineering controls, we recommend leveraging technology. This includes implementing GPS tracking for real-time fleet visibility, installing mandatory speed limiters, and utilizing driver monitoring system to actively detect signs of fatigue and distraction. Second, we address the human element through administrative control. This involves structured driver training program, strict fatigue through administrative control, and management policy to ensure drivers get adequate rest, and routine safety audits to keep companies accountable. Lastly, we cannot ignore vehicle health, which brings us to maintenance control. The proposed mandatory regular brake inspection, routine tire check, and strict adherence to preventive maintenance schedule to stop mechanical failures before they happen on the highway. Alright, that's all for my part. Thank you.
Hi and Assalamualaikum. My name is Amirul bin Azhar. My matrix number is B132310302. Today I will be presenting for my assignment for risk management framework part. The proposed risk management framework follows ISO 31000 principles. The process begins with identifying hazards such as driver fatigue, speeding, and brake failure. These risks are then assessed based on their likelihood and severity. Appropriate control measures are implemented to reduce the risk, followed by continuous monitoring and review to ensure their effectiveness. This framework helps improve safety and reduce accident rates. Next, we have several recommendations for this problem. Several recommendations are proposed based on the study. This includes implementing fatigue management policies, conducting regular vehicle maintenance, installing GPS and tracking and speed monitoring system, and providing continuous safety training for drivers. In addition, stricter enforcement of safety regulations can further reduce accident risks. For the conclusion, heavy vehicles are essential for Malaysia's transportation industry but also pose significant safety risks. Driver fatigue, speeding, brake failure, and overloading were identified as the major hazards. By implementing effective risk management strategies and control measures, accident rates can be reduced while improving vehicle reliability and overall road safety. I think that's it from our group. Thank you.